So rational functions are fractions. We're going to have a numerator and a denominator. This is in your notes, the cheat sheet. It's going to ask you to find a lot of different things. So that's why we put it all together on a cheat sheet for you. So use this for your homework. Use it to help you so you can figure out what you need to find when it asks for a certain type of question. So if it asks for the domain, you set the denominator not equal to 0. We've done that before. Since we're dealing with fractions, we can't have 0 in the denominator. So to find the domain, set the denominator not equal to 0. Domain and vertical asymptote go hand in hand. They're going to be the same values, but for our vertical asymptote, you set the denominator equal to 0. So it's the same numbers, just one's not equal to, the other one's equal to. For the horizontal asymptote, we have 3 rules that we have to follow. If the numerator degree is greater than the denominator degree, so let's say I had x to the third power over x to the second power, then we have no horizontal asymptote. If the numerator degree is equal to the denominator degree, so if I had 3x to the second power over 2x to the second power, so if our degrees are the same, then we look at the leading coefficient. So we take the leading coefficient of the numerator over the leading coefficient of the denominator. So our horizontal asymptote here would be y equals 3 over 2. And then if the numerator degree is less than the denominator degree, so if I had x to the second power over x to the third power, then our horizontal asymptote would be y equals 0. So our horizontal asymptote is always going to be y equals a number. To find the slant asymptote, we use long division to solve. So we divide the numerator by the denominator. Our slant asymptote is going to be y equals, it'll be in the form of y equals mx plus b. It's going to be a line, but it'll be in the form of y equals mx plus b. We only have a slant asymptote if there is no horizontal asymptote. So if we have no horizontal asymptote, then we'll have a slant asymptote. But you can't have both. You can't have both a horizontal asymptote and a slant asymptote. Next, we have the x and y intercepts. To find the y-intercept, evaluate f of 0. That just means you plug 0 in for x. To find the x-intercept, we plug in 0 into the y, so we just need to set the numerator equal to 0. Because if the numerator is equal to 0, the whole thing equals 0. And then to find the wholes, we factor the numerator and the denominator. Then we just set whatever crosses out, so whatever is the same, we set it equal to 0. We're going to practice all of these so you'll see what this means. But it's super, super helpful to have the cheat sheet with you when you're working out these questions. Here, it gives you visuals of what an asymptote looks like. Asymptote's this dotted line. Your graph is going to get really, really close to the asymptote, but not touch. So it's kind of like a wall in your graph. We're not going to be graphing. You don't really need to know what an asymptote looks like. We just got to find them. So let's look at example 4. We want to find the vertical and horizontal asymptotes of our rational function here. So let's start with the vertical asymptotes. To find the vertical asymptotes, we set the denominator equal to 0. So I say 2x squared plus 3x minus 2 equals 0. How would we solve this? No, what do we do to solve? Factor. How do we factor? Multiply the first times the last, we get negative 4. What are 2 factors of negative 4 that add to 3? Perfect. So 4 and negative 1. So we have x plus 4 and x minus 1. Now, if we start by multiplying the first times the last, we have to remember to divide by that first. So we're going to divide both these by 2. So we get x plus 2. If it doesn't divide, move it in front of the x. So this would be 2x minus 1. From here, just set them both equal to 0 and solve. So we get x equals negative 2. This one we have a little bit more work to do. We'd have 2x equals 1 when we add 1 to the other side, and then divide both sides by 2, so x equals 1/2. So these are two vertical asymptotes. We have x equals negative 2 and x equals 1/2. Second part of this question says to find the horizontal asymptote. For our horizontal asymptote, we have to look at the rules. There's 3 rules that we have. So we look at our highest degree. If our degree is the same in the numerator and denominator, what do we look at? We look at the leading coefficients when our degrees are the same. So we just set the coefficients equal to y. So we have y equals 3/2. So you're not doing any math to find your horizontal asymptote. You just look at the degrees and you have to follow the rules. So if our degree is the same in the numerator and denominator, then you just take the coefficients and keep it in the fraction that they're in. Next page asks us to find the domain and the intercepts. So to find the domain, we set the denominator not equal to 0. So we can't have 0 in the denominator. So we set the denominator not equal to 0 and solve. Here we just need a factor. What are 2 factors of negative 2 that add to 1? Negative 1 and positive 2. Yep, that works. So we have x minus 1 and x plus 2 equals 0. So x equals 1 and x equals negative 2 when we set them both equal to 0. Now for our domain, we have to write it in interval notation. So if it helps, put it on a number line just to see. We're talking about all the numbers except negative 2 and 1. So we're talking about all the numbers less than negative 2 and between negative 2 and 1 and from 1 greater. How would I write this in interval notation? Perfect. And then? Missing the middle part.
Oh, sure. Negative 0.
And then? Awesome. So from negative infinity to negative 2, negative 2 to 1, and then 1 to infinity. So this is our domain. Next, let's find our intercepts. So we got to find the x and the y intercepts. I'll start with the x-intercept. The x-intercept, we have to plug in 0 into the y. So we just need to make our numerator equal to 0. So 2x squared plus 7x minus 4 equals 0. How would we solve here? Factor, multiply the first times the last, we get negative 8. What are 2 factors of negative 8 that add to 7? So we have x plus 8 and x minus 1. Divide both sides, or divide both numbers by 2. So when you start by multiplying the first times the last, you have to remember to divide. So we have x plus 4. If it doesn't divide, move it in front of the x. So this would be 2x minus 1. Set them both equal to 0. So x plus 4 equals 0. 2x minus 1 equals 0. We get x equals negative 4. Same thing here. 2x equals 1. Divide both sides by 2. So x equals 1/2. Now for our x-intercepts, because they're points, we got to write them as points. The numbers that we found are going to go in the x spot, so it'd be -4, 0, and 1/2, 0. So x-intercepts, we have to write them as points. Next, let's find our y-intercept. What do we do to find the y-intercept? We plug 0 into the x's, so it's always the opposite one. So we have 2 times 0 squared plus 7 times 0 minus 4 over 0 squared plus 0 minus 2. So if it's being multiplied by 0, it just goes away. We can cross these off. So we're just left with -4 on the top. Same thing on the bottom. If zeros just go away and we're left with -2. What's -4 divided by -2? 2. Positive 2. We have to write our y-intercept as a point. The number is going to go into the y spot, so it'd be 0, 2. Any questions here? Next, for example 8, we're going to find the wholes. So wholes happen if we have the same term in the numerator and the denominator. So we have to factor and see if we have a common factor in both. So here for A, we can't factor x minus 3. It's just x minus 3. But what about our denominator? Can we factor x squared minus 3x?
Yes.
How?
By x.
We can take out our GCF, which is x. We're going to put that x on the outside, and we're left with x minus 3. Do we have a common factor in our numerator and denominator? Yeah, we've got x minus 3 that's the same. So they'll cancel out, and we would just set x minus 3 equal to 0. So what would x equal? 3. So this is where we have the whole, at x equals 3. Let's do the same thing for B. What's the GCF from the top? Awesome. So we take out an x squared and we're left with x minus 2. We have an x minus 2 in the denominator. Do we have anything in common? X minus 2. We have an x minus 2 in the top and the bottom. So if you have the same factor in the top and the bottom, they cancel. So we would say x minus 2 is equal to 0. What would x equal? X equals 2. All right, let's do example 9. So example 9 says to find the slant asymptote. The slant asymptote, we do long division. So I'm going to divide the numerator by the denominator. We have x squared minus 4x minus 5 that goes inside the box, and x minus 3 outside. So for long division, we start by dividing. What's x squared divided by x? X, perfect. So I'm going to put that on top of my x term. Then we multiply x times everything out front. So we get x squared minus 3x. What do we do next? Awesome. Change the signs and combine. So change a sign, combine. The x squareds cancel. Negative 4x plus 3x would be negative x. Then we divide. What's negative x divided by x? We have negative x divided by x. What would we get? -1, perfect. So -1 goes up top. We multiply that times everything out front. So we get negative x plus 3. What do we do next? Change the signs and combine. So these cancel. -5 minus 3 would be -8. Now this is our remainder. When we do long division to find our slant asymptote, we said before that our equation is going to be in the form of y equals mx plus b. So we just need the x term and we need the number. When you do this, you always drop the remainder. So you get rid of the remainder. Whatever your remainder is, it doesn't matter. So we just take whatever's up top and we say y equals x minus 1. So we've got our x term and our number. That's all you need. You drop the remainder, get rid of it. So looking at number 5, the first thing it says here is zeros. Zeros is just another word for x-intercept. But I'll save x-intercept and y-intercept for the end. Let's find our vertical asymptote first. Anybody remember what we do to find our vertical asymptote? Look at your cheat sheet. What do we do? Set the denominator equal to 0. So we get x squared minus 9 equals 0. X squared equals 9. Take the square root, so what does x equal? Plus or minus 3. Remember, whenever you take the square root of both sides, you need that plus or minus. So vertical asymptote is going to be x equals plus or minus 3. Let's do our horizontal asymptote next. Horizontal asymptote, we have to look at the degrees and follow our rules. So if our highest degree on the top is x squared and our highest degree on the bottom is x squared, when they're the same, then what do we look at? If we have the same degree, what do we look at? We look at the leading coefficient. So here would be 1 over 1, which would just be 1. So our horizontal asymptote would be y equals 1. So you look at the degrees. If your degrees are the same, then you look at the leading coefficient. So the numbers in front of them. Here it would just be 1 over 1, which is 1. Next, we'll find the domain next, because domain and vertical asymptote go hand in hand. How do we find the domain? We set the denominator not equal to 0. So we just solved it when the denominator equals 0. So I'm just going to change it to be not equals. So x does not equal plus or minus 3. How would I write that in interval notation? It helps put it on a number line. We're talking about every number except -3 and +3. So everything smaller, in between, and greater. How would I write that in interval notation? -infinity to -3. -3 to +3. And then 3 to infinity. Perfect. All right, next let's find the wholes. To find the wholes, we have to factor. So we have to factor our numerator and denominator. Let's start with our numerator. What are 2 factors of 6 that add to 5? Three and 2. 1 and 5 doesn't work because it doesn't multiply to 6. So 3 and 2. So up top we have x plus 3 and x plus 2. What about in our denominator? How do we factor x squared minus 9? Perfect. It's the difference of squares. So we have x plus 3, x minus 3. Do we have any common factors in the top and the bottom? X plus 3. So we can cancel them out. But we'd say x plus 3 equals 0. So what would x equal?
-3.
-3. So we have a whole at x equals -3. Next, let's find our intercepts. We'll find our x and y intercepts. So starting with the x-intercept, what do we do to find the x-intercept? We plug in 0 to y. So when I make y 0, I only need to set my numerator equal to 0. So we have 0 equals x squared plus 5x plus 6. We already factored this before, but what are two factors of 6 that add to 5? 3 and 2. So we have x plus 3 and x plus 2. So what would x equal? -3 and -2. Perfect. So our x-intercepts are, we have to write them as points. So the x value, or x-intercept, goes in the x spot. So -3, 0 and -2, 0. So our x-intercepts, or zeros, would be -3, 0, -2, 0. Next, let's find our y-intercepts. How do we find the y-intercept? Plug in 0 into the x's. So for our y-intercept, we have 0 squared plus 5 times 0 plus 6 over 0 squared minus 9. So the zeros are just going to go away. We're left with 6 over -9. What does 6 over -9 simplify to? 2 over -3. So because this is our y-intercept, it's going to go in the y spot. So 2 over -3 would be 0, 2 over -3. 0, 2 over -3. Any questions here? Very last thing, let's find our slant asymptote. Slant asymptotes only happen when we have no horizontal asymptote. So because I have a horizontal asymptote, that means I have no slant asymptote. So slant asymptotes will only happen, it happens when your degree in the numerator is 1 degree more than the denominator, but because they were the same degree, we have a horizontal asymptote, so there's no slant asymptote.